Now the question comes up that we have discussed action reaction pairs, right? Action reaction pair. We did also discuss the free body diagram. But why did we do so? We did so because the question says we've been asked to find out the action force on the system. That's why we discussed action and reaction pair. And why did we discuss free body diagram? Because using these two, we can now determine the, the magnitude of action force. Okay? How? Now, I'm pretty sure you wouldn't have taken down notes along with me in the last two solutions. Okay? At least most of us. Well, please don't be offended if you did. So, if you haven't done, right, I would humbly request you that you follow this at least, starting from this one here. And what is that we have here? We have the system moving down. So, defining the system becomes very important. What is the system we have here? Block A, block B, and of course, the flow. So these three constitutes the system. Okay. Next, we'll analyze the forces acting on it. To be more precise, this is what we call as free body diagram of A, then free body diagram of P. Well, I'm not going for free body diagram of C because we don't need that. And then we'll resolve these forces as sigma Fy and sigma Fx. And then we'll see sigma Fy is equal to MAy, sigma Fx is equal to MAX. Now, if you observe here, the system of masses are actually moving downwards like this, right? So we know that if the object is moving vertically downwards, there will be some significant SY, displacement in Y direction. But since the system is not moving neither to the left, nor to the right, we can write that displacement along X direction is equal to 0. Therefore, velocity along X direction will also be equal to 0, which implies acceleration along X direction will also be equal to 0. And therefore, mass into acceleration along X direction will also be equal to 0, which gives us sigma Fx along X direction has to be equal to 0, which justifies, right? The other way around, if there is some significant Sy, which is not equal to 0, velocity along y direction will not be equal to 0. Acceleration along y direction will not be equal to 0. And there has to be MAy not equal to 0. Therefore, there will be some significant sigma Fy, which is equal to MAy, justifying what? Okay. Now, let's try to individually analyze these two. Now, usually when we draw things, right? Free body diagram to be more specific, we draw, sorry, we make use of diagrams like this. And then we say that A is being acted by two forces, FAB and FA gravity. The reason why I haven't done it is because I find it, this is a very strong personal opinion, nothing to do with the concept and the logic behind it. Okay, it's a very strong opinion. What I do is I often draw the arrow, the head of the arrow, to the object where the force is actually experienced. So the force of gravity here actually acts on A and it has been pulled towards the earth. That's what this arrow means. So if I write like this actually means that this is originating from A and is being pulled towards earth. But usually we draw it like this, right? So there's nothing wrong in representing the same diagram in multiple ways, just to make sure that the concept is um, understood clearly. I make use of this resolution. Okay. So force on A acting due to gravity, and since A is in contact with P, there is another force acting on B by virtue of contact with being B, which is called as normal reaction on A due to B, acting on A from B. Okay. Now, looking at the second diagram, second free body diagram, which is of body B, only of this body here, body B, right? Of course, this as well. Yeah. So for the body B alone, for the body B alone, B will have a weight. Why will it have a weight? Because it is being pulled towards the earth due to gravity. So there's a force acting on B by virtue of gravity, which is usually drawn like this. But again, just to justify what my viewpoint here is, this actually would mean that the arrow is pointing towards the body which is experiencing the force, which is actually not the case here. Why? Because because the body is pulled like this, Earth and B. So what I'm trying to say is, if we draw it like this and then say that arrow, the head of the arrow represents the body where it is acting, then it is fair and to say force on B due to gravity. Now, see, sometime it's been not much. It's been very recently that I've started following this because a lot of a lot of us have this confusion regarding how to draw this arrow. They often find it confusing because they draw this using vectors, and there are of course some questions which need vectorial representation for this, and that's where things become really confusing. So it was very recent that I thought, let's try to put a uniformity into this. That's why I thought of using this one. And if I feel this is confusing, maybe in the coming solutions, I would make a change to this as well. But I think while solving questions in loss of motion, I found this as um, more clarity in it and less error prone. Okay, feel free to do the other way as well. So we have normal reaction on B due to A. Why? Because by virtue of contact with A will exert some force on B, and that will be normal reaction on B due to A. Okay. Now, by virtue of being in contact with floor, the floor will push back this object P, which will be normal reaction on P due to the floor. Okay. Now, I would personally suggest that strongly suggest that you make use of multiple colors to draw these forces. Why? Because when we consider object A and B together, right? A and B together, there are two normal reactions involved between A and B. Which all are they? Normal reaction on A due to B. Maybe I could draw it like this to have, yeah, makes sense. Normal reaction acting on A due to B. There are other forces as well, which I'm not considering for the time being. Normal reaction on A due to B. And when we consider, oh, something wrong with the diagram here. Please give me a second. Yeah. And we have object B here. That is another normal reaction acting on B due to A. I'm not considering these two forces for the time being. Now, since A is resting on B, there is no internal movement between A and B. A is neither moving up, B is neither being moved down by virtue of being contact with A and B alone. So A is resting on B. Therefore, normal reaction acting on A due to B should be equal to normal reaction acting on B due to A, which otherwise means if I consider these two, sorry, if I consider this diagram, I can say that these two forces are being equal and therefore they can be cancelled off. How do we do that? We just remove them from the system, which leaves us with only three forces: one, two, and three. So the whole free body diagram can now be drawn like this. It doesn't mean that there is no normal reaction acting here. It doesn't mean that there is no normal reaction acting here. There are, but those two forces get cancelled off. Now these are the three forces that we have here: force on A due to gravity, force on B due to gravity, and normal reaction on B due to flow. Okay. Now I can also combine this two figure. Instead of drawing it like this, I can just make one figure and represent these three forces together in it. So what I'll do is, just to make sure that we have clarity on the way we have drawn things, I'll draw this arrow. I'll keep this arrow here, and I will keep this arrow here as well. Okay. So there is normal reaction on A, there is normal reaction on B. Both of them are cancelling each other. The only forces we have: force on B due to gravity, force on A due to gravity. Why? Both of them are acting downwards and therefore are represented like that. Force on B due to the floor, which is normal reaction due to the floor, acting upwards. Now the direction of motion is acting downwards like this, right? Direction of motion is downwards. So since the direction of motion is downwards like this, there are two forces acting along the direction of motion, and there is one which is against the direction of motion, right? Why is it relevant? Because sigma Fy is equal to MAy needs calculating sigma Fy. And those along the direction of motion would be given the sign positive, and those against it would be given the sign negative. Therefore, FAG is positive, FBG is positive. Normal reaction on B due to the floor would be negative, and this will be equal to mass into acceleration of the system is given to be 0.1. Therefore, this becomes 30 into 0.1. So, what is FAG from here? Mass of A into G. What is FBG? Mass of B into G. Mass is 5, mass is 25, 9.8, so into 9.8, right? So sigma Fy will now be 5 into 9.8 plus 25 into 9.8 minus R, which is normal reaction on A due to B, equal to mass is 30, acceleration is 0.1, 49, 245 minus R is 30 into 0.1 is 3. 290 45 plus 49 is 294 minus R is 3, and minus R is 3 minus 294. Therefore, R is 291 Newton. Therefore, I'm about to address that. I do understand that there is something very critically upsetting with the question here, right? Which is, we just found out that the reaction on B due to the floor is actually equal to 291 Newton, but we've been asked to find out the action force of the system on the floor. And by Newton's third law, reaction on B due to the floor should be equal to action on floor due to the box. Therefore, the magnitude of these two will be equal to be more precise, the magnitude of these two vectors would be equal to 291 Newton, although the directions would be opposite. Therefore, the answer is 291 Newton. Okay. So, yes, I think this completes almost every aspect of Newton's laws of motion discussed in the NCRT, line by line of it. Okay. So, yes, now what is the next question about? Is this the same one regarding? Okay, now